Hello everyone. Today we'll be solving the problem circular RMQ. RMQ is nothing but the range minimum queries. So this was asked in Codeforces testing round 1, right? So here we'll be solving the circular RMQ, right? So you can just go through the question. You can just go through the question. I'll just summarize the question so that it will be easier for us to understand the problem, right? So here, what the question states, so we are given a circular array A of size n, right? So we are given a circular array A of size n. Just give me a second, 1 second. Yeah, we are given a circular array A of size n, right? So we are given a circular array of array A of size n. There are two operations. So there are two operations basically. Just keep this in mind. inc of if, this one, rg and v, right? Inc is nothing but the increment here. Inc is nothing but the increment. So we have to increment all the values if to rg. So basically this is not if, so left basically we are considering left and right. Here we are incrementing all the values from lf to rg. So it can be inclusive by v as well. We can consider if as well. So this one, this, let's consider this one lf. So this left and right we can consider this one, right? And a second one is RMQ. RMQ is nothing but the range minimum queries, right? So second one is RMQ. This one is LF comma RG. LF comma RG. Right. So this is increment. We have to increment all the values from IF to RG. IF to RG. Right. So we need to increment if all the values from if to rb. This v is nothing but this is inclusive by v, nothing but the values, right? So this rmq is nothing but the range minimum queries. We have to return the minimum value from if to rg because it is circular. Right? If if is greater than rg, it wraps around from end to start. If if is greater than rg, it wraps around from end to start. Just keep this in mind, right? So what we need to do, there are two operations, that is nothing but we have to increment all the values from if to rg. The first one inc, whatever I have written here, and the second one is rmq, range minimum queries. Nothing but we have to return the minimum value from if to rg or lf to rg inclusive, right? So these two things we have to do. These two things we have to do, right? So, and again I'm telling, we have been given circular array a of size n, right? So let me delete this one. Let's come to the input output part, man. See here, we have 4. 4 is nothing but the number of inputs, man. This one we can consider n equals 4. So in the question they have given, we are given a circular array a of size n, right? So here the size is size they have given is 4. Size they have given is 4. This is a circular array a 1 2 3 4 we have here. This one is circular array a 1 2 3 4. 4 elements we have. Size we have been given 4, right? So we have 1 2 3 4, 4 elements, and this 4 is nothing but m. M here we have been given 4, and the last 4 one, this is queries. This is queries, nothing but the RMQ. This is queries, nothing but the RMQ, range minimum queries, right? So this one 30 301 01 and 21. So two elements whatever we have been given, that is nothing but the RMQ. So 30 minus 1 we have been given 3 elements, right? So this is increment. This we have to go with the increment, right? In the increment we have to increment all the values from if to rg. If to rg means this is if, this is rg. Lf to rg, basically this is lf, this is rg, right? So other two are again queries, 01 and 21. 01 21, these three are queries. These three are this one rmq queries. This one is increment. Increment of lf comma rg comma v, that we considered, right? So the second one is increment of lf comma rg comma this one v. So these two are rmq of lf comma rg, these three, right? So I hope this part is completely clear, man. So this is the question. This is the question. Let me delete this one. So this is the question. The output that we need to get here, output that we need to get here, after performing the this one increment as well as the RMQ, means range minimum queries, and this one after incrementing all the values from LF to RG, and for the RMQ after returning the minimum value from LF to RG, the output that we need to get here is 100, right? For now we are just considering the this one input output part. We are not discussing the approach part. So just remember that they have given output 100, right, for the input this one. So n we have been given 4, and a circular array we have been given 4 elements already. N we have been given 4, so it consists of the 4 elements 1 2 3 4. This 4 is nothing but m equals 4, nothing but queries, right? So below the 4 we have been given 4 queries: 30 301, 30 minus 1, 01 and 21. So this one 30 minus 1 what we have given, this one it consists of the three elements. It consists of the three elements, nothing but this is increment part, not the query part. Increment part consists of the LF RG along with the V. It is inclusive of V. We have already discussed this one, right, in the question, right? So I hope this part is completely clear, man. I hope the question part and the input output part is completely clear. Now, as we have knowledge on the question, let's discuss the approach followed by the complexities, and then let's write the code. First, as usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question. They have given only one example within the question, right? I have considered the same example here. So this is nothing but the n, and we should have four elements, nothing but this is circular array A, and this is nothing but the m, and these are the four queries. Sorry, these three are the queries basically, and this one is increment part, right? So increment consists of one thing extra along with the LR and RG. It consists of the value as well. It consists of the value as well, minus 1, right? So the output that we need to get here is 100. Let's move on with the step-by-step explanation. Before moving on with the step-by-step explanation, so I want to just tell you that we'll be making use of the lazy segment tree for this part, right? So we have solved the problems on segment tree, but we haven't went with the lazy propagation. For this particular problem, we will be going with the lazy propagation, or we'll be going with a lazy segment tree approach, right? Just keep this in mind. We'll be going with a lazy segment tree, right? So let's move on with the step by step explanation. So same thing, we have been given input this one n equals 4, a equals 1 2 3 4 m4, and these are the four queries. This is RMQ of this one 30 minus 1 01. This is the increment part. Still it consists of the one extra element, nothing but minus 1 here, right? Nothing but value, nothing but value. Along with the LF and RG, it consists of the value as well. Right, so let's move on with the first step here. First query. So we have been given four queries, right? So we consider this one by one. 30, 30 minus 1, 01, 21, 01, 21, right? So we have three queries: 30, 30 minus 1, 01, 21, right? So let's consider first query here, RMQ of 30. So we have the circular range. Uh, the index that we need to consider is 30, right? Circular, we are going with a circular range, right? So this is the question itself states that it is circular range, right? So to go to zero, if we go from the left side, it is 3210. So this is the nearest path. We can go from 340, right? So if we go circularly, so this one will be 12340. Query we have been given 0, right? So either we can let's consider this one right side. Either we can go from here to here, or we can go from 340, right? So we will be considering the nearest one. Circular range will be index 340, 340. So we query 3 comma 0, 3 comma 0. So this one values are 4 comma 1. The values for the this one query, this one is 3 comma 0, index 3 comma 0, because we have the value circular array. We have the values this one a equals 1 2 3 4 we have been given. So index 4 consists of this one, index 3 comma 0 we are considering, right? Here we have to get the values 4 comma 1, 0 1 2 3, 3 comma 0 we are considering. So value, for the value 3 this is 4, for the value 0 this is 1, for the values it is 1, right? So minimum among the 4 and 1, minimum among 4 and 1 is 1. So we are considering the minimum among 4 and 1, so the output is 1. The output is 1. I hope this part is completely clear. Next, let's move on with the next step. So we have increment. So we have one more value addition to LF and RG here. LF and RG here, nothing but -1. So this is nothing but the increment part, not purely RMQ, right? So we have the circular range again 3 comma 0. Query part is this thing. So again we have the value in, this is inclusive of the value. So this is the increment part which is inclusive of the value 3 comma 0. Again the same thing, right? Indices 3 and 4. Again we have the values 4 comma 1, right? Values are 1 2 3 4. This is nothing but A, right? A. So we need to subtract 1 from the index 3 comma 0, 3 and 0. So this one will be A of 3 equals 4. Means 4 and 1 we have already got here. So we need to subtract this one to 3 and we need to subtract this one to 0. Right? We need to subtract this one to 0. Now updated array, we have 1 2 3 4. Instead of 1 we have to give 0. We have subtracted 1, so this one remains same, this one remains same, 2 and 3. Instead of 4 we have subtracted 1 from the 4, this one will be 3. So the array becomes 0 2 3 3. Simple one, man, right? Simple one. The array becomes 0 2 3 3, right? So now the updated array becomes 0 2 3 3, right? So this we need to this itself is the output basically for the second one, as we are going with the increment part, which is inclusive of v. First we consider 3 0, this one queries, and now -1, because here uh, for the queries 3 0 we have the value, we have the array, right, already A. For the this one is 0 1 2 3 index, basically 3 0 means for the third we have the, for the third index we have the value 4, for the 0th index we have the value 1. 4 comma 1 we have, and again, so here we have been given value -1, we have to do -1, this becomes 3 and this becomes 0. So 3 0 we have. Now in the array we have to update the array. So we have 1 2 3 4. In the value of 1 we are giving 0, in the value of 4 we are giving 3, because we are having -1, v is -1 here, right? So this becomes 1 2 3 4 becomes 0 2 3 3, the updated array. So this is the updated array. So this is the updated array, right? Very simple to understand, man. Easy, right? So let's move on with the next part here. Let's move on with the next part, step 3. So here we have been given RMQ, or the range minimum queries. We have 0 comma 1 for the third one, right? So for the third one we have C here 0 comma 1. Next one is 2 comma 1. We have 0 comma 1, right? So we have 0 comma 1. Range is pretty straight here, right? Range is pretty straight here, 0 comma 1. So now we have 0 2 2 3. We have updated the array. We have 0 2 2 3, and this is index 0 1 2 3. For the 0th index we have the value 0, and for the first index we have the value 2. So we got the values 0 comma 2. So we have to go with the minimum of 0 comma 2. Minimum is 0, right? So question itself state that range minimum queries, we are going with the minimum range minimum queries, right? So we are going with the minimum out of this one 0 comma 2. The minimum one is 0, and the output we will return here as 0. Output we will return here as 0. Again, pretty simple, right? Straightforward approach, right? So this is the output that we got here is 0 for the third query as well. So let's move on with the final query. The fourth one we have is 2 comma 1, and the array is still this one. What was the array basically? I forgot, man. Just give me a second. Array 0 double 2 3, right? So updated array is 0 double 2 3. Just give me a second here. 0 double 2 3, right? So now we have the query. We have the query. Just give me a second. What happened to this one? 1 second. Yeah, 1 second. So this one here we have got the range minimum query of 2 comma 1, right? So 2 comma 1 means index 2. So this one will be index 1 2 3. Index 2 and 1 we have to consider. Both are having the values 2. Both are having the values basically 2, right? So just give me a second here. Both are having the values 2. So indices allowed here. Why we have considered 2301? Just give me a second here. Queries we have here is this one, right? Mm, so yeah, we have to for the even we have to consider the circular range, right? We have to consider the circular range here. 1 to 2 we are considering. We have to consider the circular range here. So this one 1, 2, 3, 4, 3, 4, and 0. 3, 4, and 0. So why this is not writing? So just give me a second, man. 1 second. So this one is 4 and this one is 0. Right? 2 to 1 we are going. 2 to 1 we are going. This time we are going from the left, this side itself, right? So 2, 3, 4, 0, 1. 2, 3, 4, 0, 1. Right? So 4 we have already considered, so we will be going with the 2301. 2301, right? So this will be 230 and 1. 230 and 1, right? So the indices that are involved are 2301, 2301, right? So here the values will be, we have to consider the values at the index 230 and 1. 230 and 1. 2 we have 2 value 2. For the index 3 we have the value 3. 2 3 0 1 is 0 0 and 1 we have, right? 2 3 2 and 2. 2 3 2 and 2 basically, right? So here indices involved is 2301, right? So value we have here is just give me a second here. So this one, sorry, I have explained this one wrong. Just give me a second one. So I got confused here for the fourth query. For the first three queries, it is completely fine. We have went with the correct things. For the last one, I have explained wrong. So I thought it in a different way. What happened here is, so we are going with a range minimum query, right? So we have the values 2 comma 1. So what happens is, n in the question we have n equals 4 initially, right? And the circular array we have is a equals 1 2 3 4. N we have been given 4, right? So n we have been given 4. So the valid index becomes, we have to start with the index 0. So this becomes 0 1 2 3 for this one. 0 1 2 and 3. So the valid index becomes 0 1 2 3 here, right? So and we have the query this one 2 and 1, and this 2 is greater than 1. So as 2 is greater than 1, this means we have to go with the circular range. First value, if it is greater than the second value, that means we have to go with the circular range. We have to go with the circular range. So we will split that one as this one 2, we will be splitting this one as n minus 1 plus 0 to 1, plus 0 to 1. This one I'm speaking of, right? 2 to n minus 1 plus 0 to 1. And this becomes 2. N minus 1 is nothing but the value we have is 3 here. This becomes 3 plus 0 to 1 is nothing but we can just write here 0 comma 1. 0 comma 1, right? N minus 1 is the last but one value we have, that is nothing but the 3. So this becomes 2 comma 3 plus 0 comma 1, or 2 comma 3 and 0 comma 1 we are including here, so that I have considered place here. This is fine, man. So elements, now elements involved are this one, 2 3 0 1, right? So a of 2, becomes 3, and a of 3 becomes 3 as well. So we are updating. A of 0 becomes 0, and a of 1 becomes 2. A of 1 becomes 2. So this becomes, values becomes 3302. Values becomes 3302. This is how we got 3302. Sorry, I got extremely confused. The first three queries we went in the same way, right? So I didn't see that the value 2 is greater than 1. Those steps I didn't do at all basically. That's where I went wrong. This is fine. The values that we got here is 3302, 3302, right? So the range values will be 330 and 2. The range values will be 3302. So here we have to find the minimum among 3302. We have to find minimum among 3302. When we go with the min of 3302, 0 is the minimum number we have got. So the output will be quite obviously 0 here. So this is how we got the output 0. Sorry for the fourth one. So I really got confused for the fourth one, right? So output is here 0. Output is 0, right? So overall output, what is the output that we got here? Basically, for the first one we got 1. For the second one we have the increment, we just have to update the array. We got 0 to double 3 here, so we didn't get any output, right? For the third one we have got 0, and the fourth one we have got 0 as well. For the fourth one we have got 0 as well, right? So this one, the output that we got here is 1 0 0 1 0 0, right? So the output that we got here is 1 0 0, which is equivalent to the output that they have shown for the first example, which is equivalent for the output that they have shown for the example, right? So the output that we have got is 100, which is equivalent to the output that they have shown for the example one within the question, right? So now, as we are completely familiar with the output, as we are completely as we are completely familiar with the approach, uh, we are good to go with the complexities part. So what will be the time complexity here? The time complexity is big of logarithmic n. So the time complexity here is big of logarithmic n. uh, because we are considering four queries, right? So we are going with the range minimum queries, and it is circular, right? It is circular. Circular means if the query this side left side is greater, the value if it is greater than the right side, this one, right? So here the overall time complexity would lead to big of logarithmic n per query or update due to the lazy segment tree structure. We are going with a lazy segment tree structure, right? So we are going with a lazy segment tree structure. So overall time complexity would lead to big of log n per query or the update. So we'll be going with a query along with the update, right? So methods within the segment tree class basically. So, due to the lazy segment tree structure, overall time complexity would lead to big of log n per query or update. And what would be the space complexity? Space complexity would lead to big of n because we are not making use of any extra space for the segment and the lazy tree. Any extra space for the segment and the lazy trees. So, we will be making use of the 4n size array. We'll be making use of the 4n size array, right? So, this you'll get to know once we write the code. Again, so we will be making use of the 4n size array. Overall space complexity would lead to big of n, and the time complexity would lead to big of n per query or update, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of logarithmic n per query or the update and big of n respectively, right? So now, as we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. So let's start writing the code now. So we'll be making use of the input output, nothing but the fast input output, buffer reader and the print writer, and we'll be going with a different utility package as well. I mean different utilities as well. So let's import input output and the util package, right? So I'll just go with import java.io.star. This is fine. Let me go with import java.util.star. So this is fine. Next, let's go with the class main. So I'll just go with class. So did I hit the caps lock? So this is fine. So I can just give any name man, that is relevant to the question. You can just give the question name as well. So I'll just give main here, the class main. So or as we had discussed in the this one approach, we'll be going with a lazy segment tree, right? So let's go with the lazy segment tree class here for the range updates and the range minimum queries, right? So I'll just go with static class. So this one will be lazy segment lazy segment tree. This is fine. So within the lazy segment tree class, first let me go with the size. So this will be size, um, nothing but the size of the original array. Second, we'll be going with the segment tree array, nothing but here long tree, and the third one is nothing but lazy propagation array. So this one will be long lazy, right? So let me come out of this one entirely. So the next, let me go with the constructor, nothing but we will be building the segment tree from the input array, right? So initialization part, constructor. So I have given lazy segment tree. This one will be lazy segment tree. The parameter will be this one, input array, because we will be building the segment tree from the input array itself, right? So within the constructor, let me initialize size to length of the input array. So this will be input array dot length, right? So the next one, let me go with the tree. Let me initialize this one to long of size, as we have already discussed in within the complexities, that we will be going with a 4n, or here 4 into size. Same thing. Let me initialize lazy to new long, again 4 into size. The last one is we have to start building from the root node, right? So I'll consider here build tree. So this one will be input array we have to start from 0 to we are starting from the root node basically, right, to the last one, nothing but size minus 1. So I hope this part is clear, man. Let me come out of this one entirely. So we are done with the constructor part. Let's move on with the further things. Means we have to build the tree recursively, right? So we had discussed in the approach that we will be going with a uh, this one, a query and the update we will be going. First, what we need to do, we have, as we are going with the lazy propagation, we will be building the tree recursively, and we will be going with the propagation. Propagate means we have to push the pending updates to the children, nothing but the lazy propagation. We are going with the lazy propagation for this particular problem, right? So first three problems we had solved, the problems on pure segment tree, right? Pure segment tree. This problem we are going with the lazy propagation, segment tree along with the lazy propagation. So let's go with the first two methods will be build and propagate. Propagate means lazy propagation. Build tree means we will be building the tree recursively. First, let's go with the build method. So I'll just go with void. So this one will be build tree. So I have already made use of the build tree method within the this one. So I should have written this one later after writing this method. So don't mind. So I have already written this one, right? So don't get confused how we got build tree here. This is not any operation or this one, right? So I am making use of the same method over here. So I should have written this one after this, right? So this is fine, right? So let's build the tree recursively. So the parameters that we'll be considering here would be array. So this one will be node, this one will be left, and this one will be right. So this is fine. So within this method, first, if left equals right, then first thing is tree of node equals array of left, right? So this is just the leaf node, right? So next thing, else we have to go with the binary search, right? So nothing but we have to calculate the mid. So this one will be left plus right by 2. After calculating the mid, either we have to go with the left subtree, right subtree, and then merge. Left subtree, right subtree, and then merge. So this is common when we make use of the this one segment tree, right? So within the build, we have to go with the left subtree, right subtree, and this one merge. So we are building the tree recursively basically, right? Here let's go with the recursion. So I'll just go with the build tree here. For the left subtree, we have to include array, but 2 into node. So this is fine. Left we are going, right? So left along with the mid, right? So this is fine. Again, let me copy the same thing. We have to go with the right subtree. Means we have to build the right subtree again. So this one will be 2 into node plus 1, and this one has to be mid plus 1, and instead of the left we have to go with the right. So let me go with the right. So mid is not required, we have already given mid plus 1, right? So this is fine. We have successfully built the left and right subtree. Now we have to merge, right? So let me go with tree of node equals math dot min of tree of 2 into node 2 into node. So this one has to be tree of this one will be 2 into node plus 1. So we have successfully merged as well. So we are done with the build method. So I'll just come out of the build method entirely. Now let's go with the propagate. Let's go with the propagate. Means we will be pushing the pending updates to the children, right? So we have to push the pending updates to the children, nothing but we'll be going with a lazy propagation, right? So I'll just go with this one. So this one will be void propagate. So the parameters I'll be going with here as node left as well as right. So this I'll be going with a right. So within this propagate method, first let me write the simple if condition. This one will be lazy of node. So if it is not equal to 0, then what I'll do, then I'll apply the pending update, right? So I'll just go with tree of node equals tree of node plus lazy of node. So this one will be lazy of node. So we are just applying the pending update here, right? So basically we are pushing the pending updates to the children via propagate method, nothing but we are applying the lazy propagation. We are going with the lazy propagation here, right? So after doing this, let me go with a simple if condition. When left is not equal to right, means I can just write here, if left not equal to right, the value I'm considering, right? If the left is not equal to right, then we have to mark the left child as lazy, right? Right, and also we have to mark the right child as then we have to mark left and right child as lazy, basically, if left is not equal to right. And then we have to clear the lazy after the propagation, right? First let's mark the left and right child as this one, lazy. So now I can write in this way, lazy of 2 into node equals 2 into node plus this one will be lazy of node. So this is fine. This one again lazy 2 into node. So this one equals 2 into node. So this one we are going with the right. We have to go from left to right. The next node. This will be plus 1, right? So this one will be lazy. We have to pass node within the array, right? So we have to pass node within the array. So we are done with this part. The next step is we have to clear the lazy after the propagation. How can we clear? This one will be lazy of node. Let me initialize this one to the 0. Let's initialize this one to the 0, right? So let me come out of this one. We are done with the propagate method, or we are done with the lazy propagation part. So now we have to go with the range update as well as the update and range query as well as the query. These four methods we are left with, basically. So we are going with the range. This problem is completely based on the range minimum queries, right? So RMQ, and which is circular, basically. The question itself indicates that. So see here, the question itself indicates that it is circular RMQ, circular range minimum queries, right? So uh, we will be going with this one. What do we call? A range update as well as the range query, along with the internal recursive update function and internal recursive query function, these two things. So this will be huge, man. So first let's go with a public function to handle the circular range update, right? So I'll just go with a void range update. So this one consists of the parameters update left, and this one will be update right, and this one will be value. So the last one will be value, basically, right? So within the range update method, first let's go with a simple if condition. When update left less than or equal to update right, update left less than or equal to update right. So this is fine. So within this if condition, so we have to go with a uh, recursive. So we have to go with the recursion, basically. So here we have to make use of the update, basically. So what I will do here, just give me a second here. So one thing I want to say here is we will be going with a one more method called update, right? So we'll be going with a one more method called update, nothing but the internal recursive update function. So before writing that one itself, I'll be making use of the update. Don't get confused here. So I am writing the word update. This is not any operation of the segment tree. So this is another method, helper method, nothing but internal recursive update function. So I'll be writing that one in the next. Before writing that one itself, am I am using that one within the range update. Don't get confused here. First itself, I have said that one, right? So I'll just go with the update here. So this one I'm speaking of. So this will be 1 comma 0. So parameter size -1, and this one will be update left as well as update right. So this one along with a long value, long value, right? So this is fine. Mm, yeah. So this, why long I have made use of this is just the value, man. Sorry. Yeah, this is just the value, update right along with the value. Else if update left is greater than or equal to update right, then we have to handle the wraparound range by splitting into two, right? So I'll just go with again update update. So this is the method that we'll be writing next actually. So this will be same. Oh, I should have copy pasted and made the necessary changes. So let me type this one quickly. So this will be size minus 1. So this will be update left. So again size minus 1. So this one will be value, right? So this is fine. So next what we'll do, let's go with the update. So this one will be 1 comma 0. This one will be size minus 1. So this one will be 0 comma update right. So this one along with the value, right? So we are just handling or we just have to handle the wraparound range by splitting into two. So this is fine. I'll just come out of this one entirely. Now let's handle the internal recursive update function. Let's go with the internal recursive update function. So we have already made use of it on this one, right? Range update method. So I'll just go with void. So this one will be update. So this one will be update. This one will be update. So next we have the parameters here, node. So this one will be int left. So this one will be left basically. So this will be right. So this one will be update left. So this one will be update right. So this one will be update right. And also we'll be going with the value which is of the type long. So this is fine. So within this method what we will do, so we will be making use of the propagate. So we have already written the propagate method, right? So this one I'm speaking of. So let me copy this one, let me paste it over here. So we are going with the propagate means we are going with the lazy propagation, right? So lazy propagation. So here propagate, why I have made use of the propagate method here, basically I have called the propagate method within the update function, right? Or the update method. So why we are doing that one, because we have to ensure or we have to make sure that all the pending updates are applied, all the pending updates are applied. So the parameters I'll pass here as node left and right. So left along with the right. So this is fine. Next we have to decide for the I mean, we have to consider for out of range, right? Bounds out of range. So here let me go with a simple if condition. So this makes it even lengthier. So this will be update, sorry, I had to consider update left. So if right less than update left or left greater than update right, left greater than update right, then what we need to do, we don't have to return anything, right, out of it. So I'll just give return here. So the final one is when update left, if it is less than or equal to left, and this one right, if it is less than or equal to update right. So then what we need to do, first we have to mark the particular node as lazy. So I'll just go with the lazy of node equals lazy of node plus this one we have to include value as well, we have to include value as well. So we have marked the particular node as lazy, and now we are going with a propagate method, right? So now we are going with the propagate method within the propagate. So we have called the propagate method again within the update method, right? So here let me go with node again left and right, man, same thing, left and right. So why we are calling this one again, because we have to apply this one immediately if it is fully covered, right? So again we don't have to return anything. I'll just give return here. I'll just give return here. So we are done with this part. So let's move on with the further things. So I'm not entirely done with the update part. So just this part, just if this if condition, these both if conditions basically, right? So now further we have to go with the binary search. We have to calculate the mid and we have to go with the left and right update, and we have to recalculate or the merge, right? So that part we are left with. Let's do it quickly. So this one will be int mid equals, so this will be left plus right by 2. And one more thing, first we have to go with the left update, right? So left update, so let me consider we are going with the internal recursive update, right? So let me go with again same thing, 2 into node comma left. So this one will be mid for the left. So we have to consider the parameters update left. So update right, this one, and we are left with value. Let me pass the value here. For the right update, all we have to do is we have to go with the mid plus one. Also, instead of the left, we have to consider right. Right. So that's what we need to do. So again, let me consider update here. So this one will be uh, 2 into node plus 1, and instead of mid this will be mid plus 1. Same thing, instead of the left we will be considering right, and the same thing, update left, update right, sorry, this has to be update right. Where did this go? Update right, and finally we are left with the value parameter. So let's pass the value here. So finally we have to recalculate, as we are going with the internal recursive update. So here we don't have to merge, rather than that we'll be going with the recalculation. This is similar to the merge as well. This is similar to the merge, we do it right. So here this one will be tree of node equals math.mun of this one will be tree of 2 into node, this is fine, 2 into node, this is fine. Again this will be tree 2 into node plus 1. So let me go with this is fine. Yeah, this is just the recalculation or the merging. So not the merging, basically recalculation. So next we are done with the update method, right? So now again the same thing we have to do with range query as well as the query. Range query nothing but the public function to handle the circular range minimum query, and only query method because we have to go with the internal recursive query function as well. So these two, as we are dealing with the lazy propagation, these two we have to write again, right? So now let's go with the public function to handle the circular range minimum query. So I'll just go with long. So this one will be range query, range query. So let me make this one capital Q. So range query. So I'll just go with the two parameters, one is query left and query right. So I'll just go with query left and int again query right. So this one, let me make this right. So within the range query method, so first step, similar to this one whatever we have written here. Not the range update. See, similar to this one basically, right? So we are going with a range query. So if the query left is less than or equal to query right, if query left is less than or equal to query right, so what we will do then? So let's return uh, query. So this one will be 1 comma 0. So this one will be size minus 1 query. This one will be query left along with the query right, along with the query right. So else what we will do, so we have to split into two ranges for the circular. So we have to split into two ranges for the circular. If it is circular means if the first value of the query is greater than the second value of the query, then we have to consider that one as circular, right? So we have to split into two ranges for circular. So here again I'm telling, so I'll be making use of the query, the method query now itself. Then I'll be writing the query method, next I'll be writing the query method, right? So don't get confused with the keyword query here, whatever I'll be writing now. So I'll just go with return math.mun here within the math.mun. If you know what I'm writing here. So after getting the this one query, after getting the query, so we have to go with the minimum value, right? We have to go with the minimum value. I showed this one in the individual queries that we considered, right? Individual four queries we had in the this one for the example one. Uh, in all the four queries we considered same thing. First we got the value. Within that particular value we had considered the minimum. Last step we had considered the minimum, the last step within each query, right? The same thing we are articulating in the form of code now. So this one will be query. So this itself I said, so we will be making use of this query, right? Query method, whatever I have made use of this one here as well. Query this one, I have not written that method yet. I have written that one directly within the range query, because we will be writing that one next. We will be writing that one next. Don't get confused here. Basically usually we'll be writing that one first, and then we will be including that one within the main method, right? So I have written that one first itself. Don't get confused here. So this one will be 1 comma 0 size minus 1. So this one will be query left, and also size minus 1. So again, this is query, so this one will be 0 size minus 1. This one will be 0. This one will be query, right? So this has to be comma. Yeah, this is fine. We are writing this one within the math.min, right? So let me give semicolon here. So we are done with the range query. So now we have to go with the internal recursive query function. So we have already made use of the query method here, right? Let me copy this one. So now first we had to write the query method, then we had to involve. So I wrote that one directly first itself. So this will be query, long query. So what are the parameters we'll be considering here? Node left, also right. This is fine. And we will be going with the query left and query right. Query left and query right. So we are done with the parameters basically. Now within the internal recursive query function, similar to the update, so we similar to the update method, so we will be going with the propagation. This one we will be going with the propagation. Where did propagation or propagate? Somewhere I wrote the propagate method, right? Lazy propagation, where is it? This one. Let me copy this one. Let me paste it over here, right? So propagate. So we will be going with node comma left comma right. So this is fine. So we are making sure that all the pending updates are applied here, right? So this is fine. Again, now the same thing, out of range, then the same thing, the fully covered ones, right? So first let's go with the out of range. So let me write the simple if condition here. This will be right less than query left, or left greater than query right. So I should have copy pasted this one. We have to return this one if it is out of range. So we have to go with long or max underscore value, max underscore value, right? So this is fine, I think. So next, what if it is fully covered? So then I have to go with if query left less than or equal to left, and right if it is less than or equal to query right. Then what we need to do, let me return here tree of node. If it is fully covered, we have to return tree of node. Nothing but similar to the merging step, right? So next let's go with the binary search here. Let's calculate mid equals left plus right. This is fine by 2. And the next part is, let me go with the left man right man. Let me go with the left man and right man. For the right man, uh, uh, nothing. Let's go with the left and right man, similar to this one man. Left one, sorry, yeah, this one itself, right? Left right, similar to this one. We'll be going with the left man and right man. So let me go with, left man here. So sorry, with leftman, this will be, we are going with a recursion here, query, right? So this will be 2 into node, same thing. Let me type this one quickly. Left, this one will be mid, and this one will be query left and query right are the parameters, right? So query left and query right. So we are done with the left main part. For the right, we'll be changing with the node plus 1. Also, instead of the left, we'll be including right. That's it. So this will be right one equals again the recursion part query. So this one will be 2 and 2 node plus 1 uh, comma mid plus 1, and instead of the left I'll be going with the right, and also this remains same, query left and query right. So this one will be query left and query right. So this is fine. Finally, we have to combine the results, means we have to get the minimum of it, right? So I'll be going with, sorry, not the right. So this has to be return math dot min of this one, left min and right min, right? So let me copy this one. Let me paste it over here, and also we'll be going with the right min, minimum of left min and right min. So yeah, we are done with the query method as well. We are done with the query method as well. Now we are left with only one thing, that is nothing but the main method, right? So that is nothing but main method. So just give me a second here, 1 second. Yeah, we are done with this one. We are left with main method, right? So here I'll be making use of throws input output exception as well. So let's go with throws input output exception, or else we'll get the error. So let me make use of it. Let's see. So within the main method, what we'll be doing first, let's go with the input output part. We haven't went with the input output part, right? So as I've said, we'll be making use of the buffered reader and the print writer. So we have involved the input output package and the different util package, right? So from the input output package, will be making use of the buffered reader and the print writer. So I'll just be going with buffered reader. So let me consider this one reader equals new buffered reader, new input stream reader of this one is system dot n, right? So this is fine. So the next one is print writer. So the next one is print writer. So this one will be print writer. So let me go with the output. Let me go with the output. So this one will be new print writer system dot out, system dot out. So let me go with system dot out. This is fine. So the next step would be here we have to go with the array size. Means we have to, here we have been given n on the input, right? Initially for the first example that they have given, or for the example that they have given in the question, we were having n equals 4, right? So we have to consider the array size, which is of the type integer. Basically, I'll just go with integer dot percent. So this one will be, I have considered a reader for the this one, right? Yeah, reader for the buffered reader dot read line. So this will be, I have to type, I think, read line. This will not show in the suggestions. So this is fine. So after considering the array size, let me go with the input array. We have considered the input array. If you remember the approach, right? So we had considered the input array. So let me go with long input array. So this one will be new long. So this has to be small l. Sorry, new long. So this is of size n. So this is fine. Next, let me go with the tokenizer. String tokenizer. So let me go with a variable name tokenizer, new string tokenizer. So this one buffered reader, we went with the variable reader. So this one again read line, read line, read line function. So this is fine. So next uh, we have to go with the iteration part, because we have to read the array. We have to read the array. We have been given circular array A within the input, right? So we have to read that particular array. So every element in the array we have to read, right? So we have to go with the iteration. So this will be for and I equals 0. This one I less than n. So this will be I plus plus. So this is fine. So next we have to read the array. We have to read the array. So this will be input array, iterated value of the input array. So this one will be long dot parse long. So this one will be parse long. So just give me a second. 1 second. Let's continue here. This will belong dot pass long. So where I have left, so we are reading the array, right? So we have to consider the tokenizer. So this one will be next token. I have not written next token, next int we have written, right? So this one is fine. We are considering the next token. This is fine. We have successfully read the array. So after successfully reading the array, what we have to do, so we have went with a lazy segment tree, right? So we have went with a custom lazy segment tree class here, this one. So let me copy this, basically this one, static class lazy segment tree. Let me copy this one. Let me come here and let me paste it over here, lazy segment tree. So I'll be going with the segment tree, this one variable name. So let me copy this one, segment tree equals uh, new. So this one will be lazy segment tree of, we have to pass the input array. We have to pass the input array, nothing but basically we are building the tree here, right? So we have to build the tree. We have already done that one. Let's go with the number of queries, man. Here we have to go with the number of queries. We are left with going with the number of queries. In the case of uh, example, what they've given in the question, so we had four queries, right? So we had four queries. One was for the increment. If you remember, 30 minus 1, 30 minus 1 1 30 minus 1 was for the increment part, right? So that one, and again 0 1 1 2. So they have given actually they had given four queries. That's what I wanted to say. Basically we are going with a number of queries here, right? So this will be int queries equal. So let me go with integer dot. So this one will be parse int of this one will be reader dot read line. So this is fine. So within the main method, so we have to check for all the queries, right? So we have to check for all the four queries. So this I can just write on this way, while queries greater than 0, then let me go with a string. This is purely related to the input output one, don't get confused here. So usually I copy paste this one, so still have time, I'm just typing this one. So this one will be a reader, nothing but the buffered reader, right? So again this one will be read line, so we have to split this one because we have the space, right? So space between the queries, individual numbers, we have space between the numbers within the input, right? So here this one I'm speaking of, yeah, 30 we have space, 301 we have space between the numbers, 01 we have space between 2 and 1 as well. So split and leave the space here, this is fine. So the next thing is I'll be going with the left and right. So here left, here this one, integer dot percent, this is fine. So this one will be parts of 0, this one will be parts of 0, and again this one will be int right. So this one will be integer, this one will be percent again. So I should have copied this one and made the necessary changes. So this will be just parts of 1 basically, that's it for the right, only difference. So we have come at the final part. So if the length of the parts is equivalent to 3, if it is equivalent to 3, then it is considered as increment, right? Not the RMQ, not the usual RMQ. So for that one also we have to write the code. So let's uh, give your parts dot length, somewhere I have used length, this is fine. If it if sorry, what did I do, man? This is fine. If it is equal to 3, we are comparing here. If we have three values basically, I'm speaking of this one, this particular input where this one 30 minus 1, right? So then what we need to do, I'll just go with the value. So this one is considered the value, the last value, this minus 1 is considered the value. We have to subtract that one, right? So within the approach I had showed the same thing. This is for the increment, this is for the incrementing, and this is considered as this different from the RMQ. This is considered as a bit different from the RMQ because this one we have only two values. For this one we have third value, nothing but value. Value we have been given, right? Along with the queries we have been given values -1 here, right? So this is inclusive to v, value v particularly. We have discussed this one in the question as well as the approach as well. So this one will be value equals, so this will be long, so this has to be capital L1. So why did I consider this one? Yeah, this one long. So this one will be parse long of parts of 2. So this is fine. Next thing is we have to perform the range update. We have to perform the range update, and for that one we have already written the range update method within the segment tree class. So I'll just copy this method, copy this method. So I'll just come here. I have made use of the segment tree, right? So variable name. So segment tree dot. So this will be range update, and we have the parameters for the range update. We have the parameters left, right, and value. So let me pass that one. Left, sorry, left, right, and value, right? So this is fine. So we have performed range update here. So if it is not, if the parts dot length is not equal to 3, then we have to perform range minimum query. So for the second one it was quite different, and for the first, third one and fourth one it was quite different, right? Queries, whatever we performed, the steps, whatever the steps I have shown, I had shown this one, what do we call, during the approach, right? If this one, if the length is 3, what for all the other things the length is 2, basically 300121, right? So if the length is not 3, else for that one I'll be making use of the else here. Else we have to just perform the range minimum query. So I can just write here um, output. So let me go with the println here. So I'll just type man, or else it will take system out println. So this one will be segment tree. So we are going with a we have to just perform the range minimum query, right? So just performing the range minimum query, so we have already written the range query method here. We have already written the range query method here. So I'll just paste it over here, range query. So the parameters we have for the range query is left and right. So this will be left and right, right? So we have successfully performed range updates here for this one. The line number 113 I'm speaking of. In the line number 115, if the length of the parts is not equal to 3, if it is only 2, then we are just performing the range minimum query. Line number 115. So now we are left with only one thing. We are done with the logical part. We have to output all the results. Means we have to flush the output basically, as we have made use of the buffer reader and the print writer. So here this one will be output dot flush. This one will be output dot flush, right? So output all results. So we are just outputting all the results here. This one output dot flush. We are done with this, right? So we are done with the coding part. Before submitting, or before checking the code with different inputs, I just want to copy paste the signature starter template. Just give me a second here. So let me come here, let me paste it over here. So let's concentrate on the logical part. So I'll just come here. So here let me copy this one. We have to get the output 100. Let's see. So let me run this one. We are getting the output. We are getting the error, sorry. The line number 49. Let me come to the line number 49 here. Where is 49? This one. If not equal to minus, I have involved here. So let me run this one again. So we have one error, that is nothing but semicolon expected. So where line number 60. So I have missed the semicolon somewhere. So yeah, let me give semicolon here. So let me run this one again. So we have some more errors, man. So this one has to be capital R. So cannot find the symbol buffered reader. Line number 109. 109. Let me go with buffered reader R capital. So this is fine. Again, new buffered reader. So let me go with R capital here. So let me run this one. Now, yeah, we are getting the output, correct output, right? 100. So there was some typos. So this is fine, man. The code is huge. I'm glad that we didn't get more errors, man. So this is fine. We have got the output 100, right? So we have only one example, right? So with different queries. So this is the code is working perfectly fine for the example that they have provided in the question, right? So this is fine. Let me copy this one. Let me come to the submission part here. So let me paste the code over here and let me hit the submit button. I hope this works for all the test cases, man. Let's see. So let's wait for some time. Here you can clearly see running on test one, right? 52C. This one, circular RMQ. Let's wait for some time. So here you can clearly see in the toast, it is showing accepted, right? So the verdict that we got here is accepted. So the code works absolutely correct on this case, right? So whatever the code that we have written works perfectly correct for all the test cases. We have successfully made use of the this one lazy segmentary approach, to be frank, right? So first three problems we had solved only using the segmentary with other things, right? So whether it may be greedy, whether it may be binary lifting and other stuff, we had made use of the segment tree, but we didn't solve any problem using the lazy propagation, right? Or the lazy segment tree. So for this particular problem, we have solved this problem using the lazy propagation or lazy segment tree, right? So I hope the solution part is completely clear, man. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.